Hello students, we'll study chapter 6, squares and square roots, which is very easy chapter. In first part of this chapter we'll learn how to do the squares of natural numbers, and we'll study some properties also, and we'll see some interesting patterns of numbers also. That is very interesting. So you have to develop interest for this chapter, then only you will enjoy. So in introduction, I would say you all know what is the formula for the area of a square. If there is a square of side L, then the area of square is always side into side. This is the formula. If side is L, then the answer will be L into L. But that was the geometry which you have learnt in lower classes. In this class, we have to do the algebra. Algebra means we'll learn how to do the square of natural numbers. So I have already written natural numbers starting from 1 to 10, and their squares are also written over here. So first of all, you should know the meaning of square. Square of any number means that number you have to multiply 2 times. Like square of 2 is 2 multiplied by 2, that is 4. Or we may write this as 2 raised to the power 2. Square of 3 can be written as 3 raised to the power 2. That is 3 into 3 is equal to 9. One common mistake I would like to discuss with you all, that some of the students, what they do, they multiply the base with the power to find the square. 3 into 2. They write the square of 3 is 6. This is very common mistake which is wrong. We should always multiply the base as many times whatever is the exponent. Power and exponent both are same. Don't get confused with this word. Exponent is also the power only. So I have written the squares of 10 numbers. Now you have to observe some patterns, some properties. If we observe the square, these are called square numbers or perfect square numbers. If we observe all these numbers carefully, what do we observe? That the last digit is either 1, 4, 9, 5, 6, and then again repeating 0 also. So no any other number, means we cannot see that 3 is written at the end or 2 is written at the end. Means only the square numbers are only ending with the digits 0, 1, 4, 5, 6 or 9. This is one observation. There are many more observations which you can see. So now if we have to define square numbers, what type of numbers are called perfect square numbers or square numbers? So we may say all the numbers which can be expressed as the product of the number with itself. This is the definition. All the numbers which can be expressed as the product of the number with itself. In mathematical terms, if we define, suppose there is a number m, and this m can be written as n raised to the power 2, where n is also a natural number. M was also natural, n is also a natural number. Then in that situation we say m is a square number or a perfect square number. And one thing we already discussed, that the square numbers always end with the digits 0, 1, 4, 5, 6 or 9 always. Now let's discuss some properties of square numbers. So first property, here I have again noted down some numbers and their squares. In first column, I have written those numbers whose squares are ending with the digit 1. Like 1 square is 1. 9 square is 81, ending with 1. 11 square is 121, ending with 1. 19 square is also ending with 1. 21 square is also ending with 1. So it means overall we can say if any number is ending with 1 or 9, then its square will end definitely with 1. The end number will be, the last number will be 1 in the square of those numbers whose last digit is 1, either 1 or 9. Second thing, I have selected those numbers whose squares are ending with the digit 6. Like the square of 4 is 16, last digit is 6. Square of 6 is 36, last digit is 6. In 14 also the last digit is 6. In square of 16 also the last digit is 6. So overall we can say if the number is ending with 4 or 6, then their squares will definitely going to end with the digit 6. So at least last digit we can guess. If the number is very large and you are asked to find out this the last digit in the square of this number, just by observing what type of digit is written in the end, we can say the last digit will be 6 or 1. One more thing. If the number is ending with the digit 0, then the square is also ending with the digit 0. Only one difference is there. In the number, if the number of zeros is 1, suppose 1, then in square the number of zeros will double. Here it is 1, so there it is 2. Here it is 2, so there it is 4, and so on. If three zeros are there in the given number, then in square number there will be 6 zeros. So it means when the number is ending with the digit 0 in its square number, it will also end with the digit 0, but the number of zeros will double. Now, some more points I have noted down here. Square of even number is even. One more observation is there, that square of all the even numbers, you can see 2 is an even number, the square is 4. 4 is an even number, the square is 16, which is again even. 8 is an even number, the square is also an even number. 10 is a even number, square is also an even number. It means the square of even number is always even. Similarly, the square of odd numbers are always odd. Like 7 square is 49, both are odd. 3 is an odd number. The square is 9, which is again an odd number. So overall we can say the square of even number is always even and the square of odd number is always odd. The second point is square numbers have even number of zeros at the end. That we have already seen, that in square number, if we count the number of zeros at the end, they are always even. 2 zeros, 2 zeros, 4 zeros, 6 zeros. So the number of zeros in square numbers are always even. Now next property, second property. In first property, we have noted down 3-4 things, mainly 3 things. Square of even number is even, square of odd number is odd, and the last thing was square numbers have even number of zeros at the end. Let's see what is given in second property. Numbers between square numbers. What does it mean? The property says there are 2n, 2 times n, non-perfect square numbers. Non-perfect square numbers means the numbers which are not perfect square, not square numbers are called non-perfect square numbers. So property is saying that there are 2n non-perfect square numbers between the squares of the numbers n and the next number, that is n plus 1. Between n and n plus 1, there are 2n, 2 times n non-perfect square numbers. Let's make it clear with the help of an example. Suppose one question is, how many non-square numbers lie between 5 square and 6 square? Suppose you have to solve this question. How many non-square numbers lie between 5 square and 6 square? So what is n? How do we solve it? We assume n as 5 and the next number n plus 1 will be 5 plus 1, that is 6. So what is 2n? Because we know the answer will be 2 times n. So if n is 5, 2 times n is 2 into 5, that is 10. So directly we can say there will be 10 non-square numbers which will lie between 5 square and 6 square. without doing any calculation, just you have to take the first number as 5, n is equal to 5 and multiply it by 2. 2 into 5, that is 10. So for the verification of this answer, let's see, 5 square is 25 and 6 square is 36. So between 25 and 36, how many natural numbers lie which are non-perfect square? I have written all those numbers. If you are going to count all these numbers, there are 10. So without writing all this, we can directly answer that there will be 10 non-square numbers. Now there are some exercises. Try these exercises in your book. Try all those questions, try to solve them, and if you have any problem, we'll discuss. Now let's see some more properties in next video. Thank you.